Hey, good morning. We're starting kind of a new section here. It's from now until Christmas, we're going to be working with linear equations, which linear just means a straight line. So you definitely need a ruler. Calculator every day always helps as well. So today we really need to start kind of focusing in on little things that we've already learned, like domains and ranges, doing quality job on our graphing with a ruler and a sharp pencil. Mechanical pencils work really well because soon we're going to be doing systems of equations, and so our answer is going to lie where the two lines cross. And so if we're not precise and accurate, then we're going to get kind of frustrated because our answer isn't going to work in both equations. So take my advice, get a ruler or some kind of a straight edge and very nice lines when you draw them. It's a little bit difficult for me to draw lines on my pad. I've been trying to figure out a way that I can move my line, but haven't quite figured that out yet. So I'll do a little Google searching tonight to see if I can work that out. Anyhow, we're starting with lesson 26. Here's the warm-up. Pause the video, and when you're done, come back and let's see how we did. All right, well, here's the answers that I got. The vocabulary part, that -5, 2 is called a coordinate. That's the points that we're going to plot. The -5 is our x value. That means left or right. And the 2 is my y value. Y means the up and down part of the coordinate. On number 2, if you missed it, notice that 2 right here is not in parentheses. So that 3 only goes to the 2, and I bring my negative sign down. Again, that's a common mistake that kids make. So that should really be a -8 there. Problem number 3, you can just plug that 8 in, and you probably did for the x, and then solve and got the y by itself. We could have monkeyed with that equation and got the 6 to the other side, divided everything by a -3, but as I look at this equation and planning my workout, if I divided everything by a -3, that'd be a 5 divided by a -3, which isn't a very nice number. So I just put the 8 in. But over here, it wouldn't take me very much because they said find the value for x. So over here, I manipulated my equation and I got the 8 y's over here. So now I have plugged the number into my equation where the x was already, where I isolated it. And it made my work a little bit easier, and I got a -1.6. On this one, you have to pay very close attention. Jenny had N dollars in her savings account, and so again, sometimes I'll make up numbers like $50 in her savings account, and she deposited, let's say, $10 in her savings account every week. Which expression represents the amount she'll have in her savings account at the end of the year? Well, 52 weeks are in a year, and so if I did that, I'd take 52 times my D, which is $10, and then I would add to it the $50 that I already had in it. So I liked A right there. Okay. D over here would take her initial amount of her savings account that she put it in times 52. That'd be really nice if that's how a bank worked, but unfortunately it's not. So today we're looking at linear functions and linear equations. Linear means a straight line. We do have straight lines. So here's our, who needs this kind of a problem? Why learn this? They can describe many real-world situations, such as distance traveled at a constant speed. You guys, most parents now have cruise control on their car, and so if we have a long distance, like I'm driving from here to Texas, and the speed limit's 65, I set cruise control on 65, and I can predict how many miles I want to go every hour. Most people believe there's no speed limit in Germany on the German Autobahn. However, many stretches have a speed limit of 120 kilometers per hour. I looked that up. That's about 75 miles per hour of our terms, because I was curious how fast that was. And so they said, well, here's our equation for the Autobahn is 120 times x. Notice that here on x we have time. So that's my x-axis. And so as I'm looking over here in hours, I have 1 hour, they plugged it in, I'm going 120 miles. If I travel 2 hours, well, I'm going to take 2 times 120 and I get 240. And so we can kind of predict as we're going along here about how far we'd go in 5 hours, let's say. All right. The graph represents a function because each domain x value is paired with exactly one range value. Sound familiar? Every domain has one and only one range value. Notice that the graph is a straight line. A function whose graph forms a straight line is called a linear function. You probably knew that from previous years. So, very, very important today as you're doing the practice sheet that you read the directions and do everything that's the directions are asking for. For example, I think they're asking for 3 things here. First direction says identify whether the graph represents a function. Then we have to explain. If the graph does not represent a function, is it linear? So they want to know, number 1, is it a function? Why? And then if it's linear, why? So let's talk about a function. I love it when they give me a graph because it passes the vertical line test. So this is a function. How come? Passes the vertical line test. Now, we want to know if it's linear as well. It is linear. Makes a straight line. This one here, it is also a function. We can say because they gave us a graph. But it is not linear. Line or the graph curves. I'll have to get my pen to be a little bit smaller writing here. Let me just do this real quick. One more color. All right. This one here, it is not a function because if I drew a line right there, it's going to hit right on all the points. So this one is not a function. Doesn't pass the vertical line test. Is it linear? It is linear. Makes a straight line. All right. I know you have to write kind of small to get all that in there, but you can do it. Work on writing small and neat. That's not very neat on my part here, is it? All right, so here's the you try it. Pause your video and do these real quick, and then I got my answers on the next page. Okay, must be done. So I got function for the first one, passes the vertical line test. It is also linear, makes a straight line. B, I got a function as well, passes the vertical line test and makes a straight line, so it's linear. Letter C is not a function, doesn't pass the vertical line test, and not linear because it makes a curved line. Now, those we've kind of done before, but sometimes when we get a table like this or coordinates, individual coordinates, it's kind of harder to determine whether it's a function or not. So I need to go turn my lights on real quick. I'll be right back. Apologize. So here's what we do when, I'm not sure how to get rid of all these things on here. There we go. Okay, so if we have a table, what we do is we look for what we call changes in our x's and changes in our y's. And so what we do is we kind of look at our x values, and as we're going down, we see if there's a pattern here. And we call these first differences. So I went from a -2 down to up to -1, went up to 0, went up to 1. So it looks like we're going +1 every time. It has to happen 3 times in order for it to be a pattern. Now let's go look at my y's over here. On my y's, I go from here to here. I do a -3, a -3, -3, and a -3. So if our differences, we call this first difference. We'll use that for quadratics here after Christmas break. We'll say, hey, these make second differences. And so, this is a +1. I think my pen just broke. All right, we'll try to make it through the period here. All right, so where were we? What were my directions? Sometimes identifying looking at the table or list or pairs. In a linear function, constant changes in the x corresponds to constant changes in the y. So what we want to know is this is a linear. It is a linear function. Sorry, my pen's going to be kind of weird here because the tip just came out. How come? X's are increasing by 1, and the y's are decreasing by 3. Okay, so that's how we do that. I'm just going to take a minute here and see if I can shove this back in real quick. Nope, doesn't look like it. All right, so let's go over here and look at my differences over here. I went from -2 down up to -1. So we're going up by 1. I went from -1 to 0, up by 1 again, up by 1, up by 1. Over here on my y's, I went from 6 to 3, so I went down by 3. 3 to 2, I went down by 1. 2 to 3, I went up by 1. So they're kind of all over the place. So this function is not linear. How come? Y's don't have a pattern. Okay, so make sure you explain. Not linear. All right. So let's look at these now. Here's where it gets kind of crazy because they give the coordinates in a table here. I don't like making a table because it takes too much time, but I'll do it both ways here. If they give me the coordinates like this, then what I do is I go like this and I make a little V on my x's. I went from 2 to 5, which is up by 3. And then from 5 to 8, I went up by 3 again. 8 to 11, I went up by 3. Then I go to my y's down here. I went from 4 to 3, so I went down by 1, down by 1, down by 1. Now you could do that same thing over here. From 2 to 5, I went up by 3s. 5 to 8, I went up by 3. 8 to 11, up by 3. Down, down 1, down 1, down 1. So this is linear. How come? And I do think they say explain. X is increased by 3. Y's decrease. Oh, boy, this makes my writing even worse. Decrease by 1. I'm going to try to get this fixed today. Now, since I have the table here, I'm just going to use the table. We went from -10 to -5, so that must mean I went up by 5. I went from -5 to 0, went up by 5, went up by 5. 10 to 6, on a 10 to 4, I went down 6. 4 down to 2, I went down 2, and 2 to 0, I went down 2. So over here, my 5, 5, 5, 5, but over here I don't have a pattern, so this one is not linear. Y's don't have a pattern. Okay, I think you try it now. So do this one real quick, pause your video, and then come on back and we'll see how you did. Okay, let's see what you did. Looked to me like it was linear. On my x's, I had 2's. I did it both ways, as you can see here. And then my y's were decreasing by 1. So again, make sure you explain on today's practice sheet. Now, this is a very important concept here. Another way to determine whether it's a function is look at the equation. A function is linear if it's described by a linear equation. A linear equation is any equation that can be written in standard form. Very, very important. Would you highlight this, please? This is called standard form. This is an example of standard form, one highlighted in yellow because it's kind of hard to see. We always put the x's first. So the a stands for a coefficient. It could be any number. So like a 3x plus 8y's. So we put the x's first, and then the y's. And then the c is always my term without a variable. Okay. Now, here's a couple of things that are rule breakers. So if x and y both have exponents of 1, that's very important. So my exponent here, we just don't write it, but both of them have an exponent of a 1. The x and the y's are not multiplied together, so I don't ever have an xy plus a y or something like that where they're together. And the x and the y don't appear to be in the denominators, so we can't have them as a fraction. We cannot have them as an exponent, and we cannot have radical signs. So if we meet all these rules, so really it's not that hard, just look for something x plus a y equals c. It's a linear equation, okay, just by looking at the equation. So if I look at this equation here, it's already in what we call standard form. And we'll do some monkeying around to get things into standard form, because that sometimes can make our graphing very easy that we don't have to use a table. But there's my x's. I have a coefficient of a 3. There's my y's, coefficient of a 2, and then here's my term that doesn't have any variables. Now on this guy, I can do a little bit of mental math here. I can get it into the form of standard form. I'd get these 3x's by minus 3x's on both sides. So it would be a minus 3x on the left side. My y is already over there, so I put a plus y. And then to get that 2 to the other side, I would add 2. And so I can put it in that form. This one here looks a little strange, but if I was to get this 5 to the other side, I'd minus 5x's from both sides. So I would have a minus 5x, a minus y, but now I have nothing. It's okay to have a 0, okay? All right. Over here, these are not linears because remember we said we can never have an x times a y. We can never have an exponent on our x's. That would make a totally different graph than a linear graph. And then what's wrong with this one? Yep, the rule says we can never have an x or a y in a denominator or a fraction. We can't have a radical either. So radical means a square root sign. Okay, that's not going to be a linear graph. So if we look at this equation right here, it's y equals x plus 3. We could write that in standard form by subtracting x from both sides. So I have a minus x plus a y equals 3. And tomorrow I'll show you why we'd want to do that. Okay, but right now this should be a linear line because we can put it into standard form. Let's pick some numbers here and get this graph. So I'm going to pick numbers like 0, 1, and 2 because we only need three points. So if I put a 0 in, 0 plus 3 is 3. So my coordinate is going to be a 0, 3. If I put a 1 in, 1 plus 3 is 4. So I have a 1, 4. Put a 2 in, 2 plus 3 is 5. So I have 2, 5. Again, hoping that this becomes a mental math for you. So what do we have over there? We had 0, 3, I believe. So there's a dot on 0, 3. I want to make this a little bit bigger. And then we had a 1, 4. Sometimes what I'll do is, since they're letting me pick 2, 5, all my dots are close together. So if they get too close together, I can pick any number I want. If I did 8, 8 plus 3 is 11. I know it's supposed to be linear. And so all these dots should fall on the same line. So you can pick whatever numbers you want. Now let's see how good I am on writing here. Now when you draw your graph and your line, use a ruler. And we want to draw it from one side of the graph all the way to the other one. Now, we draw this line, whether it's a discrete graph or a continuous graph. When we go to find answers, we have to think about it and know if we have just whole numbers. But this is kind of like a trend line. Number one, they all the dots fall onto this line. And so a lot of times in graphing, we will draw a line, even though it might be a discrete graph, just to show that we can make some predictions on other numbers on this number pattern here. Okay, so I know I've been harping discrete graphs. If they, well, not only that, they let us pick our domain here. So we can still draw a line. But when we get to word problems, we have to kind of sort that out. All right, number one, I apologize big time. Your graph paper is even worse. And I would imagine you people online, when you print it off, it's going to be even worse. So, if there is such a thing, do your very best. I'll try to find better graph paper. On your practice sheet today, it is much better graph paper. But I didn't know this one was going to come out so bad. So, graph it. I have the answers on the next page. Graph these guys. Pause your video. Oh, you know what? Back up here, now that I think about it, we're going to have some questions. We have to tell whether it's linear, and if so, if it's a function. So, yes, it's linear. We can say it's linear because it passes the vertical line test. And is it a function? Yep, it's a function. They didn't say explain, but I did anyhow. So be careful today when they say explain, make sure you explain. All right, tell whether the function is linear. If so, graph the function. So again, could we put this one into standard form? Sure could. I could subtract 5x's from both sides. I'd have a minus 5x plus y. This one's kind of strange. Where's my x's at on this one? I'm not sure what's happening to my computer here because it is going very dim. Man, I'm having all kinds of problems this morning. All right, we're going to try to make it through here. So, where's my x's at? Well, sometimes we don't write the x's, but they're still there. We just have 0 x's plus y equals 12. That says the exact same thing as 3b. Okay, so if there are no x's, sometimes I'll just put it in. Okay, how about 3c? Is that one going to be a linear line? Nope, because we can't have an exponent up there. So when we say tell whether the function is linear or not, if so, graph it. Well, we don't really have to graph that one, but sometimes it's kind of fun. When I graphed it, you'll see I graphed it anyhow. Okay. All right, so welcome back. This is the best I can do on my lines here. Yeah, when it says y equals 12, you're going to find out that that's a horizontal line across the y-axis. That when I put in any number, I always got out 12 because there's really 0 x's there. Okay, and my lights shut off one more time. So while I'm gone, will you please read those 2 paragraphs? I'll be right back. Okay, coming up to the end here. We're talking about domains and ranges. However, in many real-world situations, the domain and range must be restricted. For example, some quantities cannot be negative, such as time. We talked about that. That kind of breaks the graph sometimes. Sometimes the domain is restricted even further to sets of points. We talked about this extensively. You can't have a fraction of a person. So if we're talking about people, it's going to be like a discrete graph. Okay? All right. So here we are. Sue rents a manicure station in a salon. she pays the salon owner $5.50 for every manicure she gives. It's kind of like a rent. The amount Sue pays each day is given by this function, f of x equals 5.50x, where x is the number of manicures. Well, that makes sense. If you have one manicure, you owe $5.50. A lot of businesses work this way. Graph this function and give its domain and range. All right, so I always like to pick 0. So if I put 0 in, my function is $5.50 times 0. So that's just going to be 0, 0. So that would make sense. If I have 0 customers, I pay $0 in rent. Now, sometimes I'll kind of try to pick numbers that kind of spread things out. So let's pick a number. Well, let's just go with 2. Because I start to see a pattern here. If I do 2 times 550, isn't that $11? So I have 2, 11. So if I come over here to 2, I need to pay her, what are we counting by 5s here? $11. If I want to pick, let's do 3. What the heck? 3 times 550. I'm getting, what, 1650? 1650 is going to be about there. Now I want to pick something way far out there. Let's pick 8. 8 times 550. I'm getting 44. So if I come out here to 8 and I come up to about 44, I'll be right about there. Now I can kind of draw my line. Now, even though it's individual people that we're paying rent on, I can still kind of draw my line to kind of see where I'm going to be as far as what I'm paying this person. Okay. So now I can come back and I can make my lines, or my dots, and I can make some predictions. It's kind of not a very good scale here, but wherever I have a whole number, I'm going to make a dot. And that makes it that I don't have to do all these math problems. Okay, so now it says graph the function we did, give its domain and its range. So we can do this. We can say domain is, I could have 0. Now we have to think about how many manicures a person could give in a day. I don't know. I would imagine a manicure probably takes like maybe 8 hours. 8 people, maybe an hour each. I don't know. I don't know that my daughters have ever gotten one. So my domain is maybe 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay. That might be a reasonable domain. My range now, and this is where it's nice to have a calculator that just keeps adding or multiplying by 550. Each time I'm going up by $5.50. So I need to have 8 of them. So I have 0. So then if I have 550 times 2, that's $11. So my second one's 11 plus 550, 1650. So you people that have a calculator just keep adding plus 550. $22. You get the idea. All right. Yeah, I have syntax there. Anyhow, what's that? 2750. So when I'm all done, I'm going to count 1, 2, 3, 4, 5. I need 8 numbers down here in my range. Okay. Now on the try it one, I know you don't have graph paper like I do, so you can just do it on the same graphs. We'll do that often. So my new equation is 3x plus 10. So again, let's graph that one. On yours, just do it on the same graph paper that you had up here. Okay. We'll do that often so that we can compare. Now this person here, Sue can rent a station for $10 per day plus $3 per manicure, so she pays more up front, but she doesn't have to pay as much. He only pays $3 for every customer that comes in. So graph that one. I have that graph right next door. And when you're done, this is what you should look like. Now this is kind of important. Start looking for some patterns here. If she pays $10 up front, if she has 0 there, that's going to be $10 bucks, 0 customers. So I drew my graph, drew my line. Then for every customer, a domain. So I would have the same thing of domains here. Would probably be 0 through 10, 0 through 8. And then again, I would take my calculator and find my pattern of what I'm going up by every one, and I'd have 8 ranges here. Okay? All right. So on your practice sheet today, I'm going to print off the answers sheet, so make sure you kind of pay attention. Like for this example, for this first one here, they're asking us to do 3 things here. So make sure you follow the directions. It is a learning thing. I think some kids are kind of panicking about their grade and they're just copying the answers down, and that's not really going to help you when it comes time for quizzes and tests. Basically, it's cheating. You're not learning material. All you're doing is copying. So please don't try that. I get it. You want your grade to come up, but do it the right way. Okay? I can't monitor that. So anyhow, make sure you follow the directions. Write a set of ordered pair that satisfies a linear function. Or which set? Explain. So again, that's like 2 points on each of those questions. You have to explain what's my x's doing, what's my y's doing. I do want to make a modification on one of these as I was making the answer key. Down here when they said they do this for 15 hours. So when you're doing this problem here, I'll allow you to modify this. Let's just say she's going to do this for 5 hours. So when you do your domain and range, let's just make that a 5 hours. Okay. All right. So I'm not sure why I have that ink to shape there. Let's see what the back one is back here. Let's see if we have to modify this one. I can't remember. So it's $30 for 2 people plus $4 for every additional person. So yeah, so let's go up to 10 because they're counting by 2s. Okay, so make sure you pay attention to that domain and range when you do that. It goes up for 2 people. It starts at 2 people, and then it's plus $4 for every additional person. All right, so what would be a reasonable number for people in your family that goes to the campground? I would say probably about 5 or 6 people would be a reasonable domain or range. Even though our graph goes up to 10, we could have a party, I guess, of many people. But anyhow, most of the time, most cars fit 5 or 6 people. So I would say a reasonable domain and range there would be 0 to 6. Well, you can't have 0 because you wouldn't be going camping. So there you go. There's our reasonable. So you can't have 0. Sounds like you got to start out at 2 people. All right. So anyhow, think about that, and we'll see you tomorrow when we take standard form and we start graphing without making a table. All right. Thanks for watching today.